Okay, so now we're going to start using our addition and subtraction with radicals. And the important thing to note is that we can only add or subtract what we call like radicals. And like radicals have the same number under the same root. So in this way we can think about it as a variable. So for example, before we look at this, if we had 2x's plus 3x's, I'm sure everyone would agree this is 5x's. Because these were like terms. The same thing will happen with radicals, but we will need them to be the same. So here I'm taking the square root and the square root, both of the same number, 7. So in this case, they have like radicals. So 2 square roots of 7 plus 3 square roots of 7 is 5 square roots of 7. What we find in the following examples is that we do not have like radicals. Here we do have the square root and the square root. However, this is of 45 and this is of 20. So our goal here is to obtain or make like radicals. And we'll do that the same way we've always done it. We will simplify the radical. Through prime factorization. Okay. Alright, so let's get started. We will do the square root number 1. We have the square root of 45 minus the square root of 20. From here, the square root of 45, prime factorization. 5 goes into 45 9 times. 3 goes into 9 3 times. So that the square root of 45 could be simplified. Here I have a group of 3's. It could come out. We'll keep the same radical root, which is the square root, and anything left over, this number 5, goes underneath. Then we'll subtract and simplify 20. Taking the prime factorization of 20, 2 goes into 20 10 times, and 2 goes into 10 5 times. So the square root of 20 can be simplified by pulling out a 2, and anything left over, in this case again a 5, goes underneath. And now we've converted these to like radicals. So if I have 3 square roots of 5 and I subtract 2 square roots of 5, I simply have 1 square root of 5, which we often just write as the square root of 5. Number 2. We have 2 square roots of 12, so 2 times the square root of 12 minus 4 times the square root of 75. Again, we do not have like radicals. But we have these additional multipliers here. So let's first take the square root of 12. We know the prime factorization, 2 goes into 12 6 times, and 2 goes into 6 30 times. Now I'm going to keep this 2 out front and multiply by our simplified radical of the square root of 12. The square root of 12 has a single group of 2's, and then underneath we'll put whatever's left over which is the 3. So I have rewritten the square root of 12 as 2 square roots of 3. Now minus from what we're given, and we also have this 4. Now we need to rewrite the square root of 75. Taking its prime factorization, 5 goes into 7 one time, but there's a remainder of 2. And then 5 goes into 25 5 times. Then 5 goes into 15 3 times. So we can simplify the square root of 75. There's a group of 5s, so that 5 can come out, and again we have a leftover of 3. Now we need to continue simplifying. So this is 2 times the square root of 3. Well, I know 2 times 2 is 4, and the square root of 3 will come along. Then minus, I know 4 times 5 is 20, and the square root of 3 comes along. Now we have like radicals, the square root of 3. So if I have 4 square roots of 3, and I take away 20 square roots of 3, I have negative 16 square roots of 3. So this is going to take good note keeping and good bookkeeping to keep us clear about what we're doing. Let's look at one with a cube root. Number 3. In number 3, again we have 5 times here the cube root of 16x plus 2 times the cube root of 54x. We will keep the 5, that's a multiplier. And now I want to simplify the cube root of 16x. Well, in 16, let's find the prime factorization. 2 goes into 16 8 times, 2 goes into 8 4 times, and 2 goes into 4 2 times. I'm working with the cube root, so I'm going to look for a group of not 2 but 3, and there's one group of 3. So that 2 can come out. Then I put down the radical, remembering it's a third root. I have a single 2 left over, and there's an x as well. Plus from here, and again keep the multiplier of 2, and our goal now is to simplify 54x. Two goes into 5 2 times, but there's a remainder of 1. Then 2 goes into 14 7 times. 3 goes into 27 9 times, and 3 goes into 9 3 times. So if I was to simplify the cube root of 54x, again the index is 3, I'm looking for a cube root, so here's a group of 3, that group will come out, and then I have to put everything left behind underneath. So there's a 2 that's left behind, and also this single x. Now we can simplify. This is 5 times 2 times the cube root of 2x. Well, I know 5 times 2 is 10. And our cube root of 2x comes along. Here we have 2 times 3 times the cube root of 2x. And I know 2 times 3 is 6 times the cube root of 2x. And now we've accomplished our mission. Notice I have like radicals. It's the cube root of 2x. So I have 10 cube roots of 2x, and I add 6 cube roots of 2x. I in total have 16 cube roots of 2x. Number 4. We could take the quantity square root of 5 minus the square root of 2 and multiply that by the square root of 5 plus the square root of 2. So these are very, very close. I have a like radical here and a like radical there. I'm just off by a different sign, and this is known as a conjugate. But if we are to multiply these, let's see what happens when we have this pattern. Anytime we have to multiply, we can distribute. We'll also think about that as FOILing. So here we go. I'm going to take the square root of 5 times the square root of 5. Because these are my first terms. Then, I'll take the square root of 5 times the square root of 2. So we'll add to it the square root of 5 times the square root of 2. These are the outer terms. Now here we're going to be careful because we've got this negative, okay? So here we're going to take a negative and a positive become negative. Square roots of 2 times square roots of 5. These are the inner. And then lastly, we can take these two. A negative times a negative, a negative times a positive becomes negative. And then we have the square root of 2 times the square root of 2. And these are the last. So in total we have 4 terms. Remember, terms are separated by these plus or minuses. So we can just work term by term. Well, the square root of 5 and the square root of 5 is the square root of 5 squared plus the square root of 5 times 2 is 10 minus square root of 2 times 5 is 10, and then minus the square root of 2 squared. And now we need to simplify. The square root of 5 squared, well, that's simply 5. And in between here, what we notice is that these are like radicals. So if I have one square root of 10 and I subtract the square root of 10, this goes to 0. Then we subtract, and the square root of 2 squared is 2. And now we have 5 minus 2, which is simply 3. So notice when we multiplied these two, what we call conjugates together, that had radicals, we came up with a real number. No longer an irrational real number, just an integer. Let's try the last one. In this case, we take the quantity 2 times the square root of 3 plus the square root of 2, and then we square that. So let's write that out. 2 times the square root of 3 plus the square root of 2, again times itself. 2 times the square root of 3 plus the square root of 2. So here we have A and B being the same, or the first being the same and the last being the same, but these are not conjugates because they have the same sign. So let's see what happens here. Again, we'll need to distribute. We often talked about that as FOILing. So we'll need to take the first times the first, or 2 square roots of 3 times 2 square roots of 3. And I really encourage you to write these out and not do this in your head because there's a lot happening here. Okay. Then we will add the first and the last. Okay. So our outer terms. So that's 2 square roots of 3 times the square root of 2 plus here the square root of 2 times 2 square roots of 3. These are our inner. And then plus the square root of 2 times the square root of 2. And these are our last. And this is the outer. Okay. Alright. So, now again, we have 4 terms. We only have to work with one term at a time. First, we'll work with this one. Then we'll work with this one. Then this one. And then this one. So here, when I'm multiplying, remember I multiply everything on the outside. So 2 times 2. 2 times 2 is 4. And then we multiply what's under the radical. And the radical, here we have square root of 3, square root of 3. So this is square root of 3 squared. Plus. Again, multiply what's on the outside. There's an understood 1 here. 2 times 1 is 2. And then under the radical, we multiply. So 2 times 3. Plus. Here the same will happen. Multiply on the outside. The 2 and the 1 becomes 2. And then everything under the radical. Plus square root of 2 and square root of 2. 1 times 1 is 1. And then this becomes square root of 2 squared. And again, we still have 4 terms. So we will work term by term to simplify. So in this first term, the 4 comes along, and the square root of 3 squared is 3. Plus. There's nothing to simplify here, except we might say that that's 2 square roots of 6. And the same will happen here. We'll have 2 square roots of 6. Then plus the square root of 2 squared is simply 2. finally, 4 times 3 is 12. And everything else we could just copy. 2 square roots of 6 plus 2 square roots of 6 plus 2. And now we'll combine like terms. So 12 plus 2 is 14. Plus, we can also combine like radicals. Here I have 2 square roots of 6, and I add another 2 square roots of 6. So in the end, I have 4 square roots of 6. And this is our answer. And notice in this case, we started with radicals. These were not conjugates, and our answer still contains radicals. Okay, that is the lecture, and that will get you through your homework exercises, section 1.9, and let me know if you have any questions with them. Just go back through and keep good bookkeeping skills and be neat about what you're trying to do.